Hi, fourth grade, it's Ms. Flores with another math lesson. Today we're going to be doing lesson 98. Make sure you grab your math book, your math paper, and your power up to write the lesson practice, and we'll get started. All right, today we're going to be talking about fractions and fractions that all equal 1. All right, so if you can think of a fraction that equals 1, I will let you do that. You have 5 seconds to do that. All right, cool. Hopefully you have one in your head, or you blurted it out, or you told your parent, or you told your sibling who's standing right there, or you leaving a comment right now. Whatever you're doing, make sure you have that fraction in your head. I'm going to go ahead and show you what I have in front of me. So I have these colorful fraction pieces, and they're kind of messed up right now, so let me fix them. All right, so looking at my fraction pieces, what can you tell just by looking at all 4 circles? What do they have in common? I'll let you think about that. You might have thought that they're colorful. You might have thought that they're circles. They're all plastic. Not sure what else you've thought about, but I'm sure you've thought about other things. But one thing I want to point out is that all of them are full circles. I know, crazy, right? So if I were to take away a piece of one of these circles, okay, they are no longer the same amount of pieces, right? Obviously, we can tell that this is, all of them are missing one piece. So this still has 1 piece left. This one has 4 pieces left. This one has 1, 2, 3, 4, 5 pieces left. And this one has 2 pieces left, okay? But if I put these pieces back, okay, I get a whole circle. I get another whole circle. I get a whole circle. And I get a whole circle. So just like that, the circles are right back to being whole. So that means that even though each circle has a different number of pieces, they all equal 1. All right, so how does that work? Now, when we write these as fractions, okay, we're going to write the number of pieces as our denominator. Okay, the number of pieces as our denominator, and we have always done this. So looking at this circle right here, and I'm just going to go ahead and write straight on my desk. I know crazy things happen when you guys aren't at school. So how many pieces does this one have? We have 1, 2, 3, 4, 5. 5 pieces. Let me move this one over. Okay, so that means our denominator for this fraction is going to be 5. Okay, and since there's no pieces missing, all 5 of them are there, our numerator is going to be 5. So our denominator is 5 because we have 5 total pieces, and our numerator is 5 because all pieces are there. Not one of them is missing. All right, what about this one? We have 1, 2, 3, 4, 5, 6. So our denominator is going to be 6. And since all pieces are there, our numerator is also 6. All right, what about this one? We have 1, 2. So our denominator is 2, and our numerator is also 2. And then right here we have 1, 2, 3. So our denominator is 3, and our numerator is also 3. All of these all equal 1. Okay, they all equal 1. Every single one of these fractions equal 1. So what do you notice about these fractions equaling 1? Okay, we notice that the numerator is always going to be the same as the denominator for it to equal 1. The numerator is going to be the same as the denominator for it to equal 1. I'm going to say it again. The numerator is going to be the same number as the denominator for it to equal 1. All right, let's look at example 1 together. Example 1 says, which of these fractions equals 1? So remember when I said that the numerator has to be the same number as the what? Denominator, okay? So which one of these fractions, okay, they give you 1/6, they give you 5/6, 6/6, and 7/6. Okay, which one equals 1? Which fraction has the same numerator and same denominator? And the answer is 6/6. All right, let's look at example 2. It says write a fraction equal to 1 that has a denominator of 7. Okay, so it needs to equal 1, and it needs to have the denominator of 7. Now remember that your numerator needs to be the same number as your denominator. So if our denominator is 7, that means our numerator is also 7. Woo! All right, we're going to talk about something completely different. We're going to talk about halves. Halves. Okay, so when we have halves, half of a circle, okay, this right here is going to be 1/2 because it's only missing one piece. Okay, this right here is also half of a circle, but it's only 3 of 6, but these are the same amount of space filled into a circle. Okay, so this is still half of the circle. Okay, and then do I have another one that's half? Okay, that looks like the only one that I have as an example, but another one we can do is 2/4. Okay. All right, so these fractions are made up of our numerator are the number of pieces that we have currently present or shaded. Okay, so we have 3 pieces shaded, and to make a full circle, we would need 6 pieces. Okay, for this one, we have 1 piece here, so that's our numerator, and to make a full circle, we'd need 2 pieces, so that's our denominator. And right here, I've only shaded 2 pieces, so our numerator is 2, but all the pieces together make 4. So even though each circle has a different number of pieces, all of these circles all equal you ready for this? 1/2. Okay, that means that this is half of the circle, and half of the circle. Do you all agree that this is all half of a circle? Yes. So that means that if it's an even number, you're going to have a half in that circle. Now your denominator might be different depending on how many total pieces you have, but you can still get a half circle. All right, this takes us to example 3. Okay, example 3. A says which fraction below equals 1/2. So they give you 3 7s, they give you 6 12, and they give you 5 9. So that's asking you which numerator is half of the denominator. So is 3 half of 7? If we divide 7 by 2, do we get 3? The answer is no. Is 5 half of 9? Meaning if we divide 9 by 5, 9 divided by 5, is that the answer? Or sorry, 9 divided by 2, do we get 5? And the answer is no. Can we divide 12 by 2? Yes, 12 divided by 2 is in fact 6. So that means that 6 12s equals 1/2, and that is our answer. Okay, it's this one right here. All right, so B says which is less than 1/2. Okay, which is less than 1/2. So what is half of 7? Okay, now think about it. Half of 7 would probably be, okay, 2 goes into 7 3 times. 1. Okay, so half of 7 would probably be 3.5. Okay, 3.5. And what is half of 9? Okay, it'd probably be 4.5. So the question is asking what is smaller, okay, what is less than 1/2? And if half of 9 is probably 4.5, is 5 bigger than 4.5? Yes, it is. So it's not going to be this one, okay? Is 3 smaller than 3.5? The answer is yes. So your answer is going to be 3/7. Okay, this is less than 1/2. Okay, that means it's smaller than 1/2. Okay, all right, and moving down to letter C. Letter C says since 5 is greater than half of 9, the fraction greater than 1/2 is 5/9. So it's asking which one is greater, and we know that this one's greater. So it'd be 5/9 is greater than 1/2, since 4.5 is half of 9. Example 4 says compare 3/8 to 1/2. Now, we can say, what is half of 8? Okay, what is half of 8? We know that 8 divided by 2 is going to be 4. So is the 3 less than 4? The answer is yes. So this means that this is less than 1/2. That is one way to do it. Another way you can do it is you can draw it out. Okay. Now I got to remember how to do 8 pieces. I think it's this way. Yeah, it is. It's like a star in the middle. Okay. So, okay, right there, we can definitely see that the shaded piece is smaller than this shaded piece. Right? Let's move on to example 5. We'll do it right down here. Example 5. It says round 6 7/10 to the nearest whole number, 6 7/10. And it gives you a number line. We know that 6 and 7 are the closest whole numbers for 7/10. We know half of 10 is going to be 5, right? 6, 7. Oh, that's not spaced out very well. Let me fix that. Okay. And then 4, 3, 2, 1. All right, so we're looking at 7/10, so 5, 6, 7. So that is right here. So if our halfway mark is right here, this is our halfway mark. Is our fraction further than the halfway mark? And the answer is yes. So if your fraction is further than your halfway mark, meaning half of 10 is 5, okay, and 7 is greater than 5, it's past the halfway mark. That means we're going to round up, okay? So the nearest whole number is going to be 7. Let's look at example 6. Okay, example 6. It says estimate the perimeter of the area of this rectangle. So when we estimate, that means we need to round. So the first number they give you, and they give us a rectangle, one side has 7 7/8. Okay, the other one has 4 1/2. So since the 7 is greater than 4, we're going to have to round this to 8. Okay, we're going to have to round that up. And since 4 1/2, okay, oh, sorry, it says 1/4. Since 1/4 is less than half, because we know that 2 is half of 4, okay, we're going to round down to 4. That means we now have the numbers 8 and 4. So it's asking you for the perimeter, so that means we need to add up all 4 sides. So 2 sides are 8, so 8 plus 8, and then 2 sides are 4, 4 plus 4. So you can add it that way, or you can multiply. 8 times 2 is 16. And 4 times 2 is 8, and then you can add those two together. Okay, and what do we get? 6 plus 8 is 14. Bring down the 4, carry over the 1, and 1 plus 1 is 2. So we get 24 inches for the perimeter. Okay, then it's asking about the area. Now it's asking for the area, so then you would multiply 8 times 4. 8, 16, 24, 32. And so we get 32 inches squared equals area. All right, we got our lesson practice ready to go. Lesson practice A. It says write a fraction equal to 1 that has a denominator of 6. So going back to having our fraction equal to 1, remember the numerator has to be the same as the denominator, and therefore it is going to be 6, 6. B, which of these fractions equal 1? Again, looking at all the fractions they give us 1/10. They give us 9/10 and 10/10. So which one has the same numerator as denominator? And the answer is C. All right, question C. What fraction name it for 1 is shown by each picture? So the first picture, it looks like they have 1, 2, 3, 4, 5, 6 pieces total in that circle. So our denominator is 6. And all 6 are shaded, so we write 6 on top. And then the next one is D. Okay, D, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 little squares total, and all 9 are shaded, so 9 over 9. All right, moving down to E. Write a fraction equal to a half with a denominator of 12. Okay, so we need to make sure it equals half with a denominator of 12. So that means we need to divide 12 by 2. 12 divided by 2, and we get 6. So that means 6 over 12. All right, F. F says to compare 9 over 20 and 1/2. Okay, what is half of 20? So that means what is 20 divided by 2? 20 divided by 2 is 10. So is 9 greater than 10 or less than 10? We know that 9 is less than 10. So that means that 9 over 20 is going to be less than a half. All right, 4th grade, you can get out your math paper and do some homework problems with me. If you've already done your homework, awesome. Keep up the great work, and we'll see you next time. For those of you who are sticking around, take out your math paper, and we're going to do some math problems. All right, 4th grade, we have our math paper here, getting ready to do WP 98. The date is 4/16/20, and my name is Miss Flores. If you're still with me, you can go ahead and write your favorite color next to it. My favorite color is gold. All right, number 1, it says if the perimeter of a square is 280 feet, how long is each side of the square? So if they give us a total of 280 and there's 4 sides to a square, that means we're going to divide by 4. Okay, 4 goes into 2. We can't do that, so we need to move over to the next place value and see how many times 4 goes into 28. So we can count by 4s. 4, 8, 12, 16, 20, 24, 28. 7 times 4 is 28. 28 minus 28 is 0. We bring down the 0. 4 goes into 0, 0 times. So that means that each side is going to be 70 feet. Now, B says, what is the area? So now we're going to multiply 70 times 70. So I'm going to do that up here. Okay, and we know that don't worry about the zeros. We'll add those after. 7 times 7 is 49, and then we add 2 zeros, and we get our answer for the area is 4,900 feet square. Don't forget that little square. All right, C says give the dimensions of another rectangle that has the same perimeter. That means that we need to add all 4 sides, and it needs to add up to 280. And an area greater than 100 feet squared and less than 150. Oh my goodness. So the first thing that we need to do is we need to divide 280 by 2. Now you're going to ask me, why are we going to do that? Because that's another way that we can get another number that would add up to 280. Okay. And that's the quickest way to do that. So 280 divide by 2. 2 goes into 2 one time. 2 times 1 is 2. 2 minus 2 is 0. Let's bring down the 8. 2 goes into 8 4 times. 4 times 2 is 8. 8 minus 8 is 0. Bring down the 0. And since there's 2 goes into 0, 0 times, we get 140. Okay, now imagine we have a square. I'm running out of space. But imagine we have a square and one side is 140 and the other side is 140. Now, because we just divided by 2, now we have 2 sides left. Okay, so that means we need to subtract 1 from each side. So this now becomes 139, and this becomes 1. This becomes 139, and this becomes 1. Do you see how I did that? And now we know if we add 139 plus 139 plus 1 plus 1, it will equal 280. So our numbers are going to be 139 times 1 feet. All right, number 4 says 3/5 of the 60 trees in the orchard were more than 10 feet tall. How many trees were more than 10 feet tall? So it says 3/5 of 60. 3/5 of 60. So what do we need to do? We need to figure out how much 1/5 of 60 is, which means we need to divide 60 by 5. That's our first step. All right, 5 goes into 6 one time. 5 times 1 is 5. 6 minus 5 is 1, and you bring down the 0. 5 goes into 10 2 times. 5 times 2 is 10. 10 minus 10 is 0, so then we get 12. So 1/5 is 12, and we need to figure out how much 3/5 is. So if I were to draw a picture, 1, 2, 3, 4, 5. Okay. That means that each section we're going to have 12. Okay, so we need to figure out how much 3 of these sections are. So we simply do that by multiplying 12 times 3. I'm running out of space, I know. 3 times 2 is 6, and 3 times 1 is 3, so we get 36. And what were they? They were trees. All right, moving on to number 6. This is what we talked about today. What fraction name for 1 is shown by this circle? So that means we just simply need to make a fraction of what we see there. Okay, we see that the circle has 1, 2, 3, 4, 5, 6, 7, 8 pieces. So that is our denominator. And how many pieces are shaded? It looks like all 8 are shaded. So 8 on 8. Is the numerator the same as the denominator? Yes, so that means it equals 1. All right, right below it, we're going to go to number 9. It says to change the improper fraction 5/4 to a mixed number. Okay, so they give us 5/4. So we need to see how many times 4 goes into 5. So we're going to subtract 5 minus 4, and we know we get 1. So we're going to pull out that 1, and we're going to carry this 1 over 4. So that would equal 1 1/4. Then it says to draw it. So it might help you to draw it first instead of doing the math first. So let's just draw a 5/4. That means we need to have a circle with 4 pieces and shade in 5 pieces. 1, 2, 3, 4. So we get our 1 hole right there. Another 4, and then 5. 1/4. So that should be the same. All right, I'm going to move over to the back. All right, this is our last problem for today, and we're going to do number 28. So hopefully you can find that in your book. If you need to pause the video, go ahead and do that now. All right, number 28. It says how many 8-ounce cups of milk can be poured from 1 gallon of milk? So if you don't remember how many cups are in a gallon, you need to turn to page 488. Okay, I promise it is right there for you. Okay, page 488. Once you do that, you can count up how many cups are in a gallon. Well, I already did that for you, so we know that 16 cups equals 1 gallon. So A is going to be 16 cups, and we can just do C for an abbreviation. All right, so B says write a formula to change any number of gallons to cups. Use G for gallons to cups. So that means that if we want to change however many gallons, okay, it's going to tell us how many cups we can get. So say we have 5 gallons, we would need to multiply that by 16 to see how many cups are there total. So our equation would look like this. 16 times G equals C, because it doesn't matter what you plug in for gallons. If you multiply it by 16, you'll get the amount of cups. All right, 4th grade, that is it for today. I hope that you are enjoying math online. Let me know if you need help, and I'm here for you. Love you. We'll see you next time. Take care. Bye.